We're looking at isosceles and equilateral triangles. So first off, with an isosceles triangle, we have two congruent legs, and that's what makes it an isosceles triangle. The third side we're going to refer to as the base. Next to the base are the two base angles, and this other angle up top, which I didn't label, is the vertex angle. Now, the base angles are the legs, are the two important ones, but the vertex angle is another name, and the base is another name we may need to know along the way. Two theorems we get from this is the base angles theorem. If two sides of a triangle are congruent, then the angles opposite the sides are also congruent. So we have two sides congruent in this triangle. That means that the base angles will be congruent. The converse of this base angles theorem is if the two angles are congruent, then the sides opposite the angles are congruent. So sides gives us angles, angles gives us sides. So they work together. And that's really what we're going to look at for solving for different side lengths and angle values as we go through. Equilateral triangles, we can also add to that. A triangle is equilateral if and only if it is equiangular. So if all the sides match, then all the angles will match. If all the angles match, then all the sides match. And we can also say equiangular. If all the angles are the same, then they're all going to be 60 degrees because 180 is the total of all the angles. If they're all equal, we divide 180 by 3 to get 60. So now let's go through and start to solve. So if I need to find each angle measure in my first triangle JKL, it's important to first notice that these two angles are congruent, J and K. So we know that angle J is also 68 degrees. Now for angle L, we're going to go 180 minus 2 times 68, which gives us 180 minus 136, which comes out to be 44 degrees. So the measure of angle L is 44 degrees. Now we look over at our other triangle. We have to notice which two are the congruent angles. These two are the congruent angles because they are opposite to the congruent sides. So the 106 is actually the vertex angle. So we're going to do 180 minus 106 gives us 74 degrees. I then divide that by 2 because I know each of those angles are congruent, and we get that the measure of angle X is 37 degrees and the measure of angle Y is 37 degrees. Now moving down, we have our equilateral triangle. We have to find X, Y, and Z. We'll start with X. That is an angle. Now since this is equilateral, we know each of the angles are 60 degrees because they're all the same. So we could go 7x minus 3 equals 60. Then 7x equals 63, so x equals 9. To solve for y, since it's equilateral and I know all the sides are the same, I'm going to go 14y minus 59 equals 9y plus 1. Subtracting 9y from both sides gives me 5y. Then I'm going to add 59 to both sides, and I get 5y equals 60. Comes out to be y equals 12. Now, we have to find z. We know z, the side PR, is the same as these two as well. So I'm going to plug in a 12. I'm going to substitute a 12 for y. So 9 times 12 plus 1 gives me 109. That's what each of the sides are. So I can say that 109, which is the length of PR, is equal to 11z minus 23. If I add 23, I get 132 equals 11z, so z comes out to be 12. Okay, on to our next screen. In this first one, we have the angles are congruent, so we're going to set them equal. That's 5x plus 9 equals 8x minus 30. We're going to subtract 5x from both sides. We get 3x minus 30 on the right equals 9. We then add 30 over, and we have 39 equals 3x, so x is 13. Now to solve for y, since the angles are congruent, the sides are also congruent, so we'll say 9y minus 73 equals 3y plus 23. Subtract 3y from both sides, I get 6y minus 73 equals 23. We add that 73 over, we get 96. So y turns out to be 16 after we divide. Next problem, we lost our measurements, so we'll skip that one. Let's come down here, solve for x, and then find the angle measurements. Now this is an isosceles with my vertex angle is 104. One of my base angles is 9x minus 25. So the other one is going to be 9x minus 25 as well, because we know those two angles are congruent. So we're going to say 104 plus 9x minus 25 plus 9x minus 25 equals 180. By combining like terms, we have 18x. Then these two negative 25s become negative 50. So that's going to come out to be 54 when we add that to 104. We're going to subtract 54 from 180 and we get 126. So then we have 126 divided by 18. Just to double check, I'm going to do calculator here, and that comes out to be 7. On our next problem, it looks like an isosceles problem, so it looks like we almost want these sides to be congruent. But if we look a little bit further, we have 60 and 60. That means the third angle has to be 60. So it in fact is an equilateral problem. So we're going to go 7x plus 19 equals 11x minus 89. We're going to add 89 to the other side. So 19 plus 89 gives us 108. Then I'm going to subtract 7x, and I have a 4x on the right. So we divide 108 by 4, and we get 27. For our last one, we need to find all of these different values, but what we're going to start with is the fact that we have an isosceles triangle with this side and this side that makes the bottom right angle and the bottom left angle congruent. So that means 4x plus 3 is equal to 9x minus 47. Subtract, we get 5x. We add 47, we get 50. And we eventually get x equals 10. That's important because we plug the 10 in, or substitute the 10 in, to 4x plus 3. A becomes 43. I becomes 43. We can also look at this inside triangle. All three of these sides are the same, so that automatically means D, E, and F are all the same. They're all 60 degrees. In addition, if D and F are both 60 degrees, that means the angles next to them, the supplementary, C and H, are 120 degrees. And then last, B and G. So we have this 43 degrees, we have this 120 degrees. We need to find the third angle, which would be G. So we're going to do 120 plus 43 gives us 163. Subtract that from 180 and we get 17 degrees.